All right, so this is 8.6.3 technically. So these are some of the quiz questions from 8.6. So this first question, it says, if you use spray-on deodorant, you can find how fast it comes out of the can if you know the relative pressure inside the can. And it gives you this formula right here, which is what we're going to use. Supposing a full can of deodorant has an exit velocity V of 42 feet per second, use the formula below to find the relative pressure inside the can P in PSI, pounds per square inch. So this number that they gave us, 42, is the velocity. It's the exit velocity, how fast it's coming out of the can. So I'm going to plug in 42 for that equation. So 42 equals 7 times the square root of P. And then what we're going to do is try to get P by itself. So if I want to isolate P, the first thing I'm going to do is divide by 7. So 42 divided by 7 is 6, equals the square root of P. And then I still want to isolate P. My goal is to get P by itself. So to get rid of the square root, I square both sides. The square and the square root then are going to cancel, and I get P equals 6 squared is 36. And so that's where the answer comes from. 36 PSI, pounds per square inch. Okay, and that's it. So you'll find as we go through this, it's all the same. You have a radical or like a square root or a cube root of some sort in your equation that you're trying to isolate and get the variable inside the square root or the radical by itself, okay? All right, so the next one. Once a week you babysit your neighbor's toddler after school, usually going to a local playground. You notice that each swing on the swing set takes nearly the same amount of time, about 2.7 seconds. Use the pendulum formula below to find out how long the swing is. Round your answer to the nearest tenths. So this 2.7 seconds, we plug in for the time, okay? And then we're going to try to look for the length of the swing based on the time, the amount of time it takes for one full swing. Okay, so plug in 2.7 equals 2 pi. And then you have the square root of L divided by 32, okay? So I kind of think of, if we want to get L by itself, then technically we want to get this whole, like everything that's under the square root or under the radical by itself, okay? So I'm going to first divide by this number in front, divide by 2 pi, and then I'm going to enter that in my calculator. I know that will cancel. When I do that, I'm going to put parentheses around 2 pi on the bottom so that I make sure I'm dividing by 2 and pi on the bottom, not just 2. And then I'm going to round. I get 0.4297 equals, and all I have left over here is the square root. So the square root of L over 32. Now again, we're trying to get L by itself, so I still need to get rid of the square root first. So to get rid of a square root, I'm going to square both sides. So square that number that I just got, that big long decimal, and I get 0.1847 equals the square root of, or not the square root, we got rid of the square root. So the square root and the square cancel. I now have L over 32. And now you just have a fraction. So think of, to get rid of the denominator of our fraction, to get L by itself, I'm going to multiply by 32 on both sides. So I multiply whatever's on the bottom. So I'm going to multiply by 32, and I get, this cancels, L equals 5.91, 5.91, which is the answer. And there you go. All right, question number 5. Before radar and sonar, sailors would climb to the top of their ships to watch for land or changes in weather. If the lookout at the top of the mast can see an island 6 miles away, okay, so 6 miles away, that's our distance right here. About how tall is the mast? So here we're looking for the height. Round your answer to the nearest whole number. If necessary, use the formula for the relationship between height, h, and visibility, how far you can see, d. Okay, so we're going to plug in 6 is d, equals 5 over 6 times the square root of h. And then same kind of idea, we want to get h by itself. So technically here, you can divide by 5/6, or you could multiply by 6 over 5, like multiply by the reciprocal, however you think of it. If you are going to divide by a fraction, let's put that in parentheses. So 6 divided by parentheses 5 over 6 is how you would put that in your calculator, okay? If you multiply by the reciprocal, it would be like 36 over 5, because you do 6 times 6 divided by 5. Either way, that's about 7.2 is equal to the square root of h. And then again, to get h by itself, I'm going to square both sides. So 7.2 squared is 51.84, and the square and the square root cancel. 51.84. It said round to the nearest whole number, so that would be 52 feet. All right, number 6. A beverage manufacturer performs a taste test and discovers that people like their fizzy beverages best when the radius of the bubbles is about 0.3 millimeters. So this, if you look at your formula, this 0.3 millimeters is the radius. We plug that in there, so 0.3. According to the formula below, what would be the volume of one of those bubbles? So that's the cube root this time of 3v, oops, sorry, it's kind of sloppy, 3v all over 4 pi. Okay, so this time I'm trying to get v by itself. So again, my recommendation was if you have a fraction inside there, try to like get rid of the square root, or in this case, the cube root first. So this is a little different because this index right here is 3. It's a cube root, which means to undo a cube root, we're going to cube both sides. So I'm going to take that 0.3 and cube it. So 0.3 to the third power is 0.027. Okay, and then the cube root and the cube cancel. Now you just have this fraction, 3v over 4 pi. And then so think algebraically, to get rid of the denominator, I'm going to multiply by the denominator, which means I have to multiply by the denominator over there. So I do 4 pi times 0.027. And I get 0.339 is equal to 3v, and then I'm going to divide both sides by 3. And I get v equals 0.113. 0.113. It's volume, so that's why it's millimeters cubed to the third power, okay? Okay, we'll do a couple more here. So question 7 here. A drawbridge will sometimes open up to let boats and other water traffic pass through. As it opens, the surface of the drawbridge raises above the level of the roadway as modeled by the function. And then you can see this equation here. Now, you can also use this right triangle. So if you would rather use Pythagorean theorem, that's essentially what this is. It is Pythagorean theorem. It's just like simplified already for you. So it says that the length of the drawbridge R is 20 meters. So we're going to plug 20 in right here for R. And the point P is 16 meters above ground. That's this. So this height from the ground up is 16. Okay, so we're going to plug that in for H right here. What is the distance D? So we're looking for that. Okay, so I'm just going to use the formula they gave us and plug all those numbers in. So I get 20 equals the square root of 16 squared plus D squared. And then again, if I want to get D by itself, I want to get everything under here by itself first. So there's nothing on the outside of the radical, so let's go ahead and square both sides. So 20 squared is 400. So we've got 400 equals, now the square goes away and the square root goes away. So 16 squared plus D squared. I'm going to go ahead and subtract 16 squared from both sides. So 400 minus 16 squared, that's 144. Equals D squared. And then I know to get rid of a square now, I square root. So the square and the square root, like we're doing what we did earlier backwards. The square and the square root cancel, and then here the square root of 144 is just 12. And that's your answer. Okay? This is kind of similar. It gives kind of the same formula, and then you have the dimensions on the actual diagram. So your friend is looking at laptops for college and is comparing the different screen sizes. Use the diagram and formula below to find the height of the laptop screen. So we are looking for here the height. Round your answer to the nearest tenths place. Okay, so D is 13.3. I'm following the formula, equals the square root of W is 11.3 squared plus H squared. Okay? And then like last time, we're going to get rid of the square root first. So I'm going to square both sides. 13.3 squared. Whoops. 13.3 squared. 176.89 equals, here the big square root and the square cancel out. I'm left with 11.3 squared plus h squared. I'm now going to subtract 11.3 squared. And I just kind of enter it just like that in my calculator. So I'm going to plug that in. 176.89 minus 11.3 squared. And I got 49.2 is equal to h squared is all that I have left over there. So now think of, if I want to get, again, h by itself, that's my goal. How do I get rid of this little square? Well, I square root. The opposite of squaring is square rooting. So I square root both sides and I get h equals the square root of 49.2. I know that's going to be really close to 7.014. And so that's your closest answer. Okay. All right, number 9, you are helping with some repairs at home. You drop a hammer and it hits the floor at a speed. Speed is another word for, or I guess in this case, they're using V, velocity for speed. So speed of 8 feet per second. We're going to plug that in for V. If the acceleration due to gravity, G, is 32, so plug that in for G. 32 feet per second squared. How far above the ground, H, that's what we're looking for, was the hammer when you dropped it? Use the formula. Okay, so the speed is 8. We'll plug that in for V. Equals the square root of 2 times G, we know is 32, and then times H, which we're looking for. Okay, so again, our goal is to get H by itself here. So if your goal is to get H by itself, let's get rid of that. Everything is under the square root, so let's get rid of the square root by squaring both sides. So the square root and the square cancel, you get 64 equals 2 times 32 times h. Now this is odd because I know 2 times 32, I'm actually going to simplify that over there. That is also 64. So 64h. Now if I divide by 64 to get h by itself, all of these cancel, or technically they become 1. So 1 equals h. So it was 1 foot off the ground when they dropped it. All right, last one here. And we kind of did one like this earlier with a pendulum with our swing, okay? So the pendulum of an antique clock has been damaged and needs to be replaced. If the original pendulum completed one swing every 1.5 seconds, that's the amount of time, t, how long should the new pendulum be? Okay, so I want to find the length. Okay, so 1.5 equals 2 pi, and then square root of 1.5, or sorry, I already plugged in 1.5. I'm looking for L over 980. Okay, so here L is under the radical, so I want to get all of this by itself. Before I square both sides, I want to divide by this number that's on the outside. So let's divide by 2 pi. And then just a quick reminder, when we do that, when you're dividing by more than one thing on the bottom, we're going to make sure we put parentheses. So 1.5 divided by parentheses 2 pi is 0.2387 equals the square root of L over 980. Now you're ready to get rid of your square root. So I'm going to square both sides. Square and the square root cancel. So in my calculator, I square that answer that I just got is then 0.05699 is equal to L over 980. And then you're almost done. To get L by itself, we're going to multiply both sides by our denominator, 980. And it'll at least become a positive number. Or sorry, like a larger number. Not so tiny of a decimal. Okay, so this cancels and I get L is equal to 55.85. 55.85, so right here, 55.9. So those are some of the types of questions, actually most of the types of questions you're going to see for section 8.6.3 of Algebra 2.